Hello, welcome to my channel TKP HUB on demand of 8th class student. Today I am going to discuss about the chapter 1 of 8th class, that is rational number. Before going to the rational number, first we know about the different types of the numbers. What are they? They are, first is natural numbers. So natural number is represented by capital N. All counting numbers are known as natural numbers. When we start counting, we start from 1, then 2. So the natural numbers are the sets in which the elements are starting from 1, 2, 3, 4 up to infinite. So these are the natural numbers. Okay. Then second is whole number. All natural numbers including 0 are known as whole numbers. All natural numbers means 1, 2, 3, 4. Then we add extra 0. So the whole set represents the whole number, means 0 then plus all natural numbers, and it is represented by capital W. Then next is integer. All whole numbers including negative natural numbers are known as integers. Whole numbers means 0, then natural numbers. We include negative natural numbers means -1, -2, -3, -4 up to minus infinite. It is represented by capital Z, and the whole set is minus infinite to 0, then natural numbers. Then rational number. It is the collection of all numbers which are expressed in the form of P by Q, where Q not equal to 0. All numbers which are expressed in the form of P by Q means numerator by denominator is also known as fraction. But there is one condition: the denominator can't be 0. So there are many examples: 1 by 2, 3 by 4, -5 by 6. But we have to remember that the denominator can't be 0. Okay. Then properties of rational number. Before going to the properties of rational number, first we have understand the properties for whole number, then integer. Then it is easy to understand rational numbers. First property is closure property. So what is the closure property for whole numbers? First we check the addition. When we add two whole numbers, that is 0 is a whole number, 6 is also a whole number. When we add two whole number, the result we found that is also belong to the same category, means 6 is also a whole number. So it is said that the whole number is closed under addition. Then we check subtraction. 3 is a whole number, 5 is a whole number. When you subtract, we get -2, which is not a whole number, because in whole number we are known that the numbers 0 and then positive natural number. It is the negative natural number which is not included in the whole number set. So it is said that the subtraction by whole number is not closed under subtraction. Then multiplication. 3 into 5 is 15, is closed under multiplication. Then division. 3 division 5, 3 by 5. It is not a whole number, so it is not closed under division. Then similarly we check for integers addition. We take two integers. 3 is a positive integer, -6 is a negative integer. The result is -3, which is also belong to the integers. So it is the integers are closed under addition. Subtraction. -4 is a integer, 6 is also integer. The result is 2. So it is also an integer. It is closed under subtraction. Multiplication. -5 and -2 multiplication gives 10, which is also integer, closed under multiplication. Division. is 1 by 2. It's not closed under division because 1 by 2 is not an integer. Then second property is commutative property. Commutative property means when we add A and B from a same category, the result is also same when we reversing the number and add B then A, we get the same result. That is said that whole number or integer or rational number belongs to or satisfy commutative property. We check for rational number. I just said that what are the properties. Associative properties, we take three numbers A, B, C. First we add B and C, then we add with A, which is also equals to A, B adding first, then C. Closure property for addition, we check addition. We have to take two rational number, that is 1 by 2 plus 1 by 3. We get the LCM is 6, then 2 divided 6, 3 into 1, 3 plus here is 2, which is 5 by 6, which is also a rational number. So it is closed under addition. Then subtraction. Subtraction. When we subtract these two, 1 by 2 minus 1 by 3, we get same LCM, that is 6, and here is 3 minus 2 equal to 1 by 6, which is also a rational number. So subtraction is also closed. So whole rational number closed under subtraction. Then multiplication. When you multiply two rational number, that is the numerator multiplication, 1 into 1, 3 to the 6. So it is also a rational number. So rational number closed under multiplication. Closed under multiplication. Then division. When we divided 1 by 2, division 1 by 3, it becomes 1 by 2 into 3 by 1. When division changed to into multiplication, then after the division, the rational number or the fraction get reciprocated, means the numerator goes to denominator and the denominator goes to numerator. That is 3 by 2 is also a rational number. But if I divided 1 by 2 division 0 equals to 1 by division. Division means your denominator equals to 0. We have already read that the denominator can't be 0, so it can't be defined. So division process is not closed under division. Okay. Then commutative property. Addition. When we add that two number, 1 by 2 plus 1 by 3 equals to 5 by 6. When we reversing the number, the rational number, we add 1 by 3 plus 1 by 2, we get the same result. That is, the condition is satisfied, A plus B equal to B plus A. So it is, or the rational number, the commutative property, satisfy the commutative property for addition. Okay, satisfied. Then subtraction. Subtraction condition is A minus B equal to B minus A. If it is satisfied, then commutative property for subtraction is satisfied by rational number, or it is not satisfied, then the rational number does not obey or does not satisfy the subtraction process for commutative property. Okay, we take that same two number 1 by 2 minus 1 by 3 equal to LCM 6. 3 minus 2 equal to 1 by 6. Reversing this number, 1 by 3 minus 1 by 2 equal to LCM 6. 2 minus 3 minus 1 by 6. These two numbers are not same. Here is plus 1 by 6, here is minus 1 by 6. So it is not obey, not satisfied or not obey. Multiplication. A into B equals to B into A. When you multiply these two numbers equal to 1 by 6, also changing the position, 1 by 3 into 1 by 2, 1 by 6 same, so it is satisfied. So rational number satisfied the commutative property for multiplication. Then next is division. Condition A division B equals to B division A. 1 by 2 division 1 by 3 equals to 1 by 2 into 3 by 1, 3 by 2. Then 1 by 3 division 1 by 2 equals to 1 by 3 into 2 by 1, 2 by 3. Not same, so it is not satisfied. Not satisfied. Okay, the next property is associative property. Means we take three rational number for addition. 1 by 2 plus 1 by 3 plus 1 by 5. First we add these two numbers. 1 by 2 plus 5 3 LCM 15 is 5 plus 3 equals to 1 by 2 plus 8 by 15. LCM is 30. 15 plus 16, 31 by 30. So for right hand side, 1 by 2 plus 1 by 3 plus 1 by 5. First we add these two numbers. So LCM is 6. 3 plus 2 then plus 1 by 5. 5 by 6 plus 1 by 5. LCM 30. 6 divided 5 5 is 25 plus 5 divided 6 6 31 by 30. So it is, these two results are same, so it is satisfied. The rational number satisfy the associative property for addition. Satisfied or obey. Second, subtraction. In commutative property we see that the rational number does not obey. Here also does not obey. Third, multiplication. It is satisfied multiplication process for associative. Satisfied. Then division. Division is not satisfied. Okay, understood? Role of 0. When we add 0 to a whole number, we get that whole number. When we add 0 to an integer, we also get that same integer. When we add 0 to a rational number, we also get the same rational number. So that is 0 is known as additive identity. Additive identity, because when we add 0 to a number, we get the identical number. 1 by 2 we get that identical number, so known as additive identity for all numbers. that like that, rule of 1. When we multiply 1 to whole number, we get that whole number. When we multiply 1 to a integer, we get that integer. When we multiply 1 with rational number, we get that rational number. So 1 is known as multiplicative identity. 1 is known as multiplicative identity. Okay, 0 is known as additive identity, 1 is known as multiplicative identity. Then additive inverse. Additive inverse or negative of a number. Okay, let consider a rational number is 5/4. Negative of this 5/4 equals to negative of 5/4 equals to minus 5/4. When we add these two numbers, 5/4 plus minus 5/4, we get same LCM. Then 5 minus 5 equal to 0/4 equals to 0. So when we add a number to its negative, we get 0. So it negative of a number, or it is known as additive inverse. When you add the negative of a number, we get the result 0. Okay, so example, additive inverse of minus 3/5. We just change the sign. Negative of a number, so negative number is minus of minus 3/5, minus plus 3/5. So additive inverse or negative number, just we have to change the sign of that number. Then multiplicative inverse. Multiplicative inverse or reciprocal. We check by using that same reciprocal number is 5/4. Multiplicative inverse means we have to change the numerator to the denominator. The multiplicative inverse is multiplicative inverse equals to 4/5. The denominator goes to numerator and also numerator goes to denominator. When you multiply these two numbers, we get 1. So it is known as multiplicative inverse or reciprocal. Example, reciprocal of 2. So 2 is a rational number. Any number can be rational. 0 is also a rational number because denominator is always 1. So what reciprocal means, we have already told that or known that denominator goes to numerator equals to 1, then numerator goes to denominator. 1/2 is the answer. Okay, next is representation of rational number on number line. Previously everybody had known that how to represent a natural number, whole number, and the general number line is, here is 0, left side is negative, right side is positive. Everybody had known this. But representation of a rational number, we have to represent 3/5 and minus 2/5 on number line. How it will represent? First we take a line. Here we have to show that both positive and negative, so we take 0 in the middle, at the middle. Then here is 1. Look, here is 1. But the denominator is 5. Look how I write. 1. I also write that 5 by 5 is 1. Denominator, the denominator, whatever the denominator, we have to take large like that. If the denominator is 7, we take 7 by 7. Here is denominator 5, so we take 1 as 5 by 5. So 0 also 0 by 5. Then denominator same, we have to increase the numerator. 1 by 5, 2 by 5, 3 by 5, 4 by 5, then 5 by 5. Also minus 1 by 5 to the left side, minus 2 by 5, minus 3 by 5, this type. So our requirement is 3 by 5. 3 by 5. This is the representation of rational number on number line, and minus 2 by 5 is the minus 2 by 5. Okay. Then next it is very important question, that is find two rational number between 4 and 5. 4 and 5, in between 4 and 5 we have to find two rational number. The first method is method 1. We have to add these two numbers, then divided by 2. Okay, first we add 4 plus 5 division 2, we get 9 by 2. 9 by 2 is a rational number. Then I just show a number line. Here is 4, here is 5. 9 by 2 is how much? 2 4 is 8. 9 by 2, 2 4 is 8. 1.0 to 5 is 10. Just 4 by 4.5 means 4.5 is in between 4 and 5. We get the rational number between that two numbers. This is the process. We just add the two number and divided by 2. Then 9 by 2 get here. We also get the second. This is the first rational number. First rational number. Similarly we get the second rational number by adding 4 plus 9 by 2 by 2. We get the rational number in between these two numbers. Also we can add 9 by 2 plus 5 by 2. Any number you can add. 4 plus 9 by 2 divided by 2. First we solve this. 2 4 is 8 plus 9 by 2 by 2 by 2. Here is 1. 17 by 2 into 1 by 2. 17 by 4. The second rational number. This is the first method. The second method is 4. Here is 5. Here is 4 by 1. Here is 5 by 1. We just multiply any number, but any number in both numerator and denominator as per requirement. If the question is find 10 rational numbers, we have to multiply that type of number, 10, 100, this like. Over here I also multiply 10, here also 10, same number we have to multiply. This becomes 40 by 10, this becomes 50 by 10. These new two numbers are 40 by 10 and 50 by 10. When we cancel, we get the same previous number, 4 and 5. So in between them the denominator is same, the numerator differentiate, numerator ranges from 40 to 50. So this our requirement two rational number is 41 by 10, 42 by 10, or many as 43, 45, 44 by 10, as like this. This is the whole rational number for chapter 1. Thank you.